strategy?
Well, I'm Andrew Simchuk, and I work in product development. I'm an FCG.
Okay, so we're going to tell you a little bit about Ford Motor Company, kind of what we do, a little bit about type of engineers we look for, and just talk about a little bit about our programs and really what makes a good engineer. So, first off, I just want to kind of talk about a little history of Ford and LTU. We've partnered for about 80 years. They were part of the original move over to the Southfield campus. We have over 1,200 LTU alumni at Ford. It's great, and whether they're employed or retired, but I'm an alumni from 1999 mechanical engineering. I've been at Ford since 2000, and there are a lot of us running around. So, but before we get started, I kind of want to just take a quick quiz and just kind of educate you on Ford and see what you know about it so far. So real quick, how many years has the F-Series been the best-selling truck in the U.S.? Any quick guesses? D. Great choice. 38 consecutive years, best-selling vehicle for the last 32. 1925, we built tri-motors airplanes. So how many tri-motor airplanes were built by Ford?
B.
It's B. The answer is
Oh,
yep, 199. So just to let you know that our proving grounds in Dearborn actually used to be the airport for these planes before it was an actual vehicle test ground. So, okay, how many hybrid battery electric vehicles does Ford Motor Company offer? C. And the answer is 4. We have a full non-gas BEV for the Focus. We have hybrids for C-Max Fusion, have HEV and plug-in, which is a gas tank and a high voltage battery, and then the Lincoln MKZ, which is just a regular HEV. Okay, the GT40 won the Triple Crown, in the Daytona, Sebring, Le Mans with 1, 2, 3 finishes in each race during what year? A. Wow, that's pretty quick. The answer is yes. Right. Okay, talking about our Super Duty diesel, how much torque does the 2015 Power Stroke Ford diesel produce? We love power.
C.
C. We love power. Answer's D. More the better.
More than that.
So what Ford vehicle sold 1 million units in its first 18 months?
B.
B. Wow, that's right. 1966 Ford 65 Mustang. Okay, how many vehicles does Ford Motor Company offer that achieve at least 40 miles per gallon? Remember your answer from earlier.
Hybrid consistency.
Right, look at that. You're paying attention. Okay, how old is Ford Motor Company today? C. 113. You are much more knowledgeable in this morning's class, I will tell you that. So,
Pretty impressive.
This was one of my favorite facts about Ford I found while putting these questions together. Who invented charcoal briquettes?
D.
D as in dog. Henry Ford. Actually, it was his son-in-law who had the idea, and then Henry Ford himself went and just ran with it and created it. He was a pioneer of taking materials that people that were scrapping, just reusing them for something different. So that's actually pretty cool to know, since I was using Kingsford when I was a kid. Okay, how did the original GT40 get its name?
C.
Wow. 20 inches tall. Nice. Okay. All right, well, if you got 5 to 9, you're excellent. If you got all 10, wow. But here's kind of just a fun tiebreaker. So which of the following is not a technology available in Ford vehicles today? This morning's class got this one right.
Good questions. A? No, it's B.
I hear A and B.
B.
B. The answer is B. So we do actually make the other 3. And actually, for me, I was actually on the inflatable belt design team for 5 years that I developed and launched that. So that's pretty cool technology. Okay, so a little bit about myself. I am a former alumni of Lawrence Tech. I graduated in 1999 with a bachelor's in mechanical engineering. I continued to go through Wayne State University to get an MS in biomedical engineering. I love developing seatbelts and safety, so I did a lot of cadaver testing, a lot of new seatbelt development. Very cool. So I was in the biomechanics group for about 6 years before moving to another part of my career within Ford, which led me to an MBA, Michigan State. So I've been at Ford roughly since 2000. I was in the Ford College Graduate Program, like Andrew is today. I rotated a lot of different spots, some crash, some marketing, some vehicle dynamics. I worked in advanced safety for about 6 years. Then I moved over to powertrain fuel systems. I've done everything from hardcore design, testing, application engineering, program management. I've led teams to develop new technology for diesel engines, gas engines, safety technology. I moved over to a group in 2013, so my group team basically is responsible for developing the overall business corporate landscape. So we basically develop every strategic decision for product, non-product, and footprint decisions twice a year with our senior management. So with the changing landscape of the auto industry, we really every 6 months reassess how we spend our $50 billion budget to temple. So that's about me. And
So my name is Andrew Shimchuk. I just recently graduated from here, but I have an electrical degree. It's a little different, but I finished in 2015 in May. The biggest, most impactful thing that I did as part of my Lawrence Tech career was Formula Hybrid. So I would strongly advise all you guys, when you guys are picking a senior project, pick one that's hard and impactful, because hybrid is one of those, but there are others on the other Formula teams would be like that.
And
估计他是拿第2名的那个。
Excuse me?
我操，他就是拿第2名那个。
What do you? Well, I mean like on
这辆
the.
车是他是队长。 他现在
I
在
can
福特。
I can talk to you more about that later, because yes, but I'd be glad to explain that.
But I would recommend getting involved in SE. I did the SE Formula One car when I was here, and I tell you, it was outside of internships, it was the best thing for interviewing. I mean, you take something from your brain to the board, fundraise it, you design it, you manufacture it, test it, and then you actually compete with it. I had so many job interviews when I was finished because this project gave me the full product development experience in college. It was awesome.
Yeah. So my work history is substantially shorter than Chad's, but I had various internships while I was in college. I started right after I got out of high school, so I was doing stuff in seating and in lighting, automotive lighting. And then I started with Ford in July, so I gave myself this 10-week break between school and work. That is great, the last 10-week vacation I'm ever gonna get. So that was great. And so, but for my first rotation, I did electrical systems. So systems is the big picture, how the whole car goes together. And so I was on an early model, so it was how the schematics were going together, making sure every piece of tech was gonna be able to fit on the car. Then my second rotation, which is my current one, is design and release, and that is much more focused, much more specific. I do clusters, so your instrument panel, your gauges that show you your driver information, I have to know everything about those clusters on my program. And so that's been a different kind of skill, because instead of knowing how everything fits, I just have to know how everything interacts with this one piece. My next rotations that I'm looking forward to is another systems one, but this one's gonna be a building systems one, where I'm gonna have all the actual parts. It's not gonna be planning anymore. And then we'll go down to Kentucky, and I'll be launching the new Expedition Navigator, which that's gonna be sick, because that launch rotations are very hands-on, very intense. You have to be solving problems on the fly, and I've heard a lot of good things from my friends who have done them. My last rotation is going to be in planning and strategy, because I enjoy big picture stuff. And so I wanted to see what is the big picture for Ford? How are we going to be positioning ourselves? And so that's my final rotation. I'm going to start in late 2017.
Okay. So before we go into the FCG program, I just wanted to talk about the work study program that another LTU person helped me this morning. Basically, you have the availability to work at Ford 16 to 30 hours a week, give or take, while you're a full-time student. So there is a lot of different ways to do this. I'll have a slide at the end that kind of gives you a website that you can look for them on. But there are possibilities to work as a part-time during the school year and full-time over the summer while you're attending school. So
one note on this is that these positions are very much as they're needed on a less planned basis. So a really good way to try to get one is to send your resume to. On our team, we give it to Shannon Dare, who leads our recruiting. And when anyone needs an intern, or a work study participant, that's who they go to. And so that would be the way to get these positions.
there you go.
What was her name?
Shannon Dare, if you have
provide the contact
Yes,
information to
yeah,
the
contact
professor
information,
with
yeah.
our presentation, whittled down a little bit after we're done with this class today, so.
So this is my section, FCG program. Well, I guess Chad did it as well, but I've really enjoyed it. The FCG program is a 32-month program that allows you to rotate between different groups. The idea behind it is to take promising engineers and show them different parts of the company so that A, they can learn how the different parts interact, and then B, find out what is the one that they want to do. And so you can see you start in a home group, and so you see all these different choices of home groups: sport, performance, powertrain, manufacturing, that give you a baseline to work on. And then during that time, there's different base, call it template rotations you do to kind of get the experience in the home group, and then you can also do electives. So for me, my elective is my strategy and planning rotation, which yeah, I'm looking forward to a lot. But the coolest part about the FCG program is how flexible the rotations are. If you can find the people that would want to take you, you can do it. And so that's been my experience. You have to talk with your mentor, but with that, for the planning and strategy, it was an email to the whole FCG community, and it was asking, is anybody interested in this rotation? And I was like, yes! And I wrote an email to the supervisor, had an interview with her, and she was like, okay, cool, we'll take you when you're done. And so it was that easy. And so another thing with your mentor, every FCG gets a mentor, and those are L5s, managers have about 50 people under them, so they have a lot of experience. They know their way around the workplace, so they can give you good advice. And that's been really helpful to me, because when I came in, I didn't know anything, except anything like of how the workplace worked. And so that was a really cool experience learning from him. So, yes.
My experience with this also, I did mine between 2000 and 2002. I have 15 friends that I didn't even know until I was in the SCG program, and we're like closest friends today. They also don't work at Ford, but they're all still a very big part of my life. The SCG gives you a chance to network with people all over the company with like social activities and training events. So it is a very comprehensive. The goal is to come out with basically knowing a lot of different people, that it's more of an advantage over someone who does a direct hire into, say, chassis or powertrain. So, okay. So now we're talking about kind of different characteristics that make a good engineer. I just kind of use these as, read points, but first of all, analytical skills. I mean, to be an engineer, you really need to understand how to analyze things. So example would be, if you're an application engineer, okay, and you have a problem, you need to understand the root cause. So you really need to understand how to data mine, look at test results, try to figure out what is wrong with it, and then also, how do you come up with a solution for a root cause? So analytical skills are also very important if you're a CAE modeler and you're trying to develop a model from physical test data that you're using. Again, very analytical. You need to understand how to look at data, how to process it, and use it to actually make a decision, right? Attention to detail. I mean, this is critical with an engineer or without an engineer. My experience would be that anytime you are looking to solve a problem, you need to be in the granular weeds to understand what the issue was. I'll give you an example. I spent my time in powertrain. We went to our first fuel system that was for a plug-in hybrid that was sealed, which meant that we had to create a natural vacuum by creating a vacuum pump. Doing that, we created a whole onboard diagnostic monitoring system. This was the first fuel system that had so much electronics in it. We were writing code, and it was kind of on the fly. And I spent 4 days sleeping in our lab, trying to figure out driving vehicles with a team of 20 people. At the end of the day, it was 2 lines of code that basically had one trumping one test over the next. But the level of detail needed to find that was absolutely critical for us to even come up with what the problem was. The solution was rather easy, but to find that root cause was very, very difficult. Communication skills. I mean, if you're an engineer or any job you do, communication is so key. I'll give you an example. 7 years ago, we have 5 business units, right? We have one in Asia Pacific, one in Europe, one in Middle East Africa, South America, North America. 2006, 2007, we literally were 5 different business units. We ran things independently. I had no idea what my counterparts did. We had our own processes, own templates. And then Alan Mullally came, started, breaking down barriers, And people like me would bleed trying to commonize templates, design processes with other cultures. So over the last 10 years, I have learned to work with every type of culture on this planet on launching new technology to solving current design problems on technology that are on the vehicles on the road today. You need to really understand and listen to everyone's point of view. All the different cultures are very different. You have to understand how they think and how they process and how they engage. And if you're able to do that, the results, I can tell you, are astronomical. I've launched new technology in a silo. I've also been involved in safety projects with Volvo, where they invented the seatbelt in the 50s, so they are the king of safety. We'll call you, don't call us. And I've been on 2 projects that literally failed because they did not want to work with us, and it was really unfortunate. I've been able to launch 2 different technologies in powertrain with the benefit of working with engineers all over the world. Not just engineers, people in finance, people in purchasing, my suppliers, my supplier engineers, my manufacturing engineers. All together, you need that to launch a product. To give you an example, when I kick off a new project, I need to pick suppliers. So I have design competitions, I work with purchasing, and I'm very engaged with them to, I could have 15 suppliers on one commodity. I need to work with finance to make sure that my budget and targets are set for that vehicle program over the 4-year period. I have to work with my calibrators, I have to work with my other application engineers, manufacturing engineers, like throughout the process of prototype builds, in the prototype plant, doing builds in the mass production plant, making sure that the supplier plants, that they are making parts up to specs, working with the suppliers to make sure the test data meets my engineering specifications. So all that is absolutely critical if you launch a product from, cradle to grave. Without communication, you will get nowhere. So, and that even goes for a hardcore design engineer and sits in a half-lit room all day and designs things. Well, you know what? They need to know what they're designing. They need to understand what the issues are. What are the challenges? So even the most hardcore design engineer need communication skills to make a project successful. So, if please have any questions throughout, just raise your hand, and we don't have to wait to the very end. Continuing education, I think that this is so important, especially that the way the world is changing from a technological standpoint, whether it's automotive, whether it's medical. I've been in the field for 20 years. I'm pretty well educated, but as I work in strategic planning, I can develop a business case, I can do a financial report. I understand the basics of all engineering principles, but as I start to look at autonomous vehicles and electrification portfolio and connectivity, those are things that are not, new, that are just not, natural for me, right? So with your age, that's your space. So I need to constantly educate myself to know what is going on, what is the challenges of, what is autonomous vehicle going to want in 5 years? What is the customer? What's the technology? What are our competitors doing? If I decide to not launch a vehicle in 2018, what other competitors are launching that vehicle? What market share am I losing? What technology is not going to be offered to the customers before that other OEMs will be offering those customers at that year? So again, always learn. I love my job because I love what I do. I'm always learning. I'm challenging myself. I'm not bored. So anytime that you're bored at work, you should take the initiative, ask, but challenge yourself. And I think that if you take that lesson for anything you do, you will always just enjoy what you do as you go through your career the next 10 to 40 years. So,
one interesting note on that is, with a company that's as big as Ford is, I could be doing different jobs for 150 years and still not do everything. And obviously my career will not be that long, but when you're in a huge company, there's lots and lots and lots of factors to learn, and that's fascinating.
Yeah, I mean, I've had 3 separate careers in Ford, and they also paid for my 2 graduate degrees, so I've got no complaints. So, and anytime you work in the professional world, companies offer tuition reimbursement, take advantage of it. Start getting the work experience, and let the companies pay for grad school. That's a great way to do it. Be creative. I mean, this is so critical now, especially from examples that I have, working in product strategy. You know, as we work on certain vehicle programs, we work with the design studio hand in hand. Like we have full clay models, like my office is literally across the street, or across the hall from the full-size clay vehicle models. So we're going in there and we're looking at them, and we're saying, okay, you know, this is like what's gonna look like, this is a trim level, from everything from the full body to a steering wheel. Those folks are awesome. I mean, they're basically more artistic. They are understanding what the customer wants from marketing that we kind of funnel to them, and they come up with different, you know, clay versions. Sometimes, most of the time, they're small at the very beginning before you know make a huge one. But you know, that's the kind of creativity that you need to have to be competitive in the space for, you know, in automotive. But also as an engineer, whether you're designing, you know, the next widget, or if you're trying to figure out a problem that someone can't figure out, you know, being creative and thinking out of the box is, my experience, been the best way to solve problems. You know, try to look beyond